All right. Hi, everyone. I'm your instructor, Kanessa EO. Couple things I wanted to do in this short concept review is kind of build it out like a problem that you would see on some type of exam, and I'll use an example from an old exam I used to utilize, and throughout it we'll work through building out a lot of concepts that you've worked through with respect to calculating GDP, trade balances, compound growth, real GDP, and growth rates. And so it'll pack a lot of, I think, maybe some of the more concerning topics into a short video, but we'll work through it in this problem structure. So we'll go ahead and get started. What we have here, and let me zoom this in just a little bit. So what we have here is an example where we have a country, and we're given a lot of information with respect to variables. So I have my gross private investment sitting at $340, my government spending at $420, consumption at $660, imports at $200, and exports at $150. First question here just asks us to calculate the nominal GDP. In order to do that, I just set up our general expenditure approach. So in the expenditure approach, let me highlight, we're utilizing our consumption plus investment plus government spending, and then we have our trade balance as that last variable. And so that one will vary with respect to the variables that or the quantities that you're given for each of these variables. In our case here, if we set up our problem correctly, we end up with a trade deficit. So this actually ends up being a negative variable on our nominal GDP. So first part's relatively easy, setting up the structure, and we take the sum while accounting for our trade deficit here, and we're able to address our nominal GDP in that year. The next question then highlights that trade deficit. So if your X minus M, so if your country is importing more than it's exporting, meaning we're buying more goods, bringing more of those into the country relative to what we're exporting out or selling to other countries, then we're operating at a trade deficit. This is just like the US. But if you're exporting more relative to what you're purchasing from other countries, so your X is larger than your M, then you're going to be operating in a trade surplus. In our case here, we have a deficit, so negative 50 deficit. We take that into account in our nominal GDP. Next question is more difficult. In 2023, our country Z's nominal GDP is 1640. So we have a different year. So a couple of years into the future, we see that in terms of nominal GDP, we've grown. And the question asks us, in 2023, we're going to use that as the base year. So use 2023 as the base year and calculate real GDP for our country in 2020. So this is the one we're calculating it for. When the GDP deflator or the price index, GDP deflator is a price index, is 89 in 2020. So we set up our formula, and real GDP is really easy to calculate. It's nominal GDP divided by our price index divided by 100. The important thing here is that we do this first. Do that first. Sorry, 89 divided by 100, so we get 0.89 in the denominator, and we end up with our nominal GDP from 2020, which is what we calculated in part A. 1370 divided by 0.89 gives us our real GDP in 2020. Then it asks, what's our country Z's real GDP in 2023? And that one, we don't have to do anything. It's really easy. All we have to do is recognize that we use 2023 as the base year. Whenever we choose our base year, it's arbitrary. That lets us know that our nominal GDP is going to be equal to the real GDP, because the price index in the base year is going to be equal to 100. So we're going to be dividing by 1. Okay. Next, use our real GDP calculated in Part C and the real GDP in Part D, so we have these two pieces of information, to calculate the growth rate across that period. Has it grown or fallen over this time period? And our growth rate, put simply, is very easy. So you have like a more formal definition in the slides, but if you want to take an easier approach, whenever you're calculating the growth rate, just new minus old divided by old times 100. And so the new is the 2023. That's our updated year. New is 1640. So I get 1640 minus 1539 divided by 1539. And that gives me this growth rate here. The last one is our compound growth. So the compound growth formula is a little more complicated. It's also known as like a future value formula. You can use the same formula if you're thinking about estimating your investments into the future. So if you're anticipating a return of like 4% on average over the course of a long period of time, then you can use the same formula to think about, like, if you were to save $200, how much would that grow over the course of a certain fixed period? But the formula is relatively easy. We're using, or let's set up the question first, use our nominal GDP and estimate country Z's GDP in 20 years with a growth rate of 1.5%. So, compound growth formula. First thing we need is your GDP at start date. So our GDP at our start date is 1370. If you were doing this for a savings account, this would be your initial investment. But in our case, 1370 is our GDP at start date, multiplied by 1 plus that growth rate. So we have to convert this to a decimal here. So 1.5% in decimal form looks like 0.015. And so we need, like, order of operations here, we need to do this part first. So let me highlight this. We need to do our 1 plus 0.015, that gives us 1.015 raised to the 20th power. Once we do that, we can multiply that by our GDP at start date, and that will give us our estimated GDP 20 years into the future. So just a short video to break down like a couple different concepts that tend to be a little more math intensive and sometimes can be a little more intimidating. Big thing for the exam is don't use like different AI tools with related to math. A lot of times it will do these order of operations incorrectly. So follow this procedure and you should be fine with these questions.